Hey everyone, today we will be creating our own custom Terraform module from scratch. So Terraform is a tool for creating infrastructure on the cloud through code rather than clicking endless menus on a GUI console. With Terraform, we can define our infrastructure as code, making it easier to automate and manage our cloud resources effectively. And modules are just pre-written Terraform codes which can be reused instead of writing the same code over and over again. Alright, now let's understand our architectural diagram. This outermost box is our AWS cloud. Imagine it as a garden or a park. Inside this AWS cloud, we have our own virtual private cloud. Imagine it like your own private corner of the park, which only you have access to. Within this virtual private cloud, we divide our space into subnets, just like different sections of the park. In this, we have one public and two private subnets. Let's say we have a web application and I want everyone to access the front end. So we will deploy the front end in the public subnet and the backend and the database will be deployed in the private subnet so that no one can access them. And inside this public subnet, we have two EC2 instances. They are virtual servers that are running our front end of our web app. And in the same way, the backend and the database should be deployed in the private subnet. But in this project, we are not deploying any EC2 instance in the private subnet. And these are the availability zones. They are just different data centers in a region. I will not go deep in this. Understand in this way, region is like your whole city and availability zones are different branches of your bank in that city. Simple. They are used for high availability and fault tolerance. Let's say your database is in zone A and it has some error, but your application will not stop working because the same database is available in zone B. Okay, and this is internet gateway. Its job is to enable instance in the public subnet to connect to the internet by instructions provided by the route table. In the case of public subnet, we allow all the incoming traffics indicated by a CIDR block. This indicates that all the incoming traffic are allowed. An instance inside the public subnet will be associated with a public IP address, which is used to access the internet. And note every subnet has their own route table. I've not drawn the route table for a private subnet because we will not add a NAT gateway in our code. Let's draw NAT gateway just for understanding purpose. These are the route tables for the private subnets and this is the NAT gateway. In the route table which are associated with the private subnet, this one, they are configured to have all outbound traffic. The route table which are associated with the private subnet are configured to have all outbound traffic, which is opposite to the route table which are associated with the public subnet. They are configured to have all inbound traffic basically. So let's say instance, there is an instance EC2 instance and this EC2 instance or database needs internet connection. So what NAT does, it translates or transitions the private IP of the instance or database to a public IP so that it can access the internet while keeping the privacy for a private instance. We will also define an application load balancer. It operates as a seventh layer of the OSI model, the application layer. It allows you to distribute the incoming application traffic across multiple EC2 instances with the help of target groups. Target group, in this case, group of instance. These are group of instance and there are listeners. Let me draw a diagram of application load balancer. Don't worry, I made this properly this time. This is application load balancers, and inside the application load balancer we have two listeners. Okay, these users are hitting on the IP with a particular port, and these listeners are listening on a particular port. And if a particular port is hit, let's say a user tries to access this port, and if the port is hit, the listener will redirect the traffic to a target group. And last but not the least, we have our RDS database, which is also in private subnet and in two different availability zones. So moving on, let's talk about how will be our project execution flow. We'll write our Terraform code in VS Code and deploy through Ubuntu VM, so that you can also follow with me with an EC2 instance. Talking about our EC2 instance, the only prerequisites of this project is you should have an AWS account. So let's begin. So let's start by creating a GitHub repository to sync file between VMs. Now that our repository is created, let's clone it. Let's open this directory in VS Code. For starters, we'll need to install Terraform in our VM. So let's open our Chrome. Let's search for install Terraform. Yes, this one. We'll click on the first link, and R is Linux VM, and we'll execute these command one by one. Our Terraform is installed. We can verify it by Terraform help. We can also use version. Both works the same. Let's clear the screen. Our Terraform is installed successfully. Next, we'll need AWS CLI to control our AWS account through command line. We'll use, yes, the same way we'll execute all the commands one by one. We can use AWS flag version to verify the installation. Okay, now clear the screen, and we'll remove these two files, AWS and the zip file. And now we have to create a user in our AWS account. Go to the IAM dashboard and click on user, create user, give it a name, we'll call it Hulk. Click on next. We'll attach the policies directly. We'll get administrative access to all, and you can add any tags. We'll give it a name, Terraform module project. Click on create user. Our user created. Now we have to create access keys. Click on next, and if you want, you can give a description tag. Click on create access keys. Our access keys are created. Your VM, you can, to configure, you can use AWS configure, and just copy and paste your access keys and secret access keys. And remember, do not show these keys to anyone. And I'll clear the screen first. Yeah, and see, now my access keys and secret access keys of my AWS account is configured. You can verify it by seeing your S3 buckets in your account. See, I have only one S3 bucket, so my account is configured correctly. We will be using US West 1 as a default region for the entire project. We are all set. Let's start creating our project. First, we'll create all the required files. Okay, now we'll need AWS provider. Let's find it. Terraform, not this, Terraform, yes, AWS provider. We'll click on use provider button and we'll copy this code and paste here. We'll remove the provider block from here and put in the provider.tf file, and region we will using US West 1, correct? So let's now create a backend for our project. It will save the state of our project in an S3 bucket with state locking. State locking will do with DynamoDB. What it means I'll show you. But yeah, the backend should be in separate directory, because if we destroy the infrastructure of the current project, the state will also be destroyed. So I'll remove this because I'll not need a backend for my backend. My providers.tf looks good. Resource, we need to add a S3 bucket and a DynamoDB table. So we'll find it here in the documentations. We'll search S3 bucket. Yes, this one. And we'll use a basic one. Yeah, this will work. Let's paste it here, and now let's change the name of the bucket and the tags. Okay, now we need a Dynamo table. This one, yeah, DynamoDB. Let's make the screen black and we'll search for a table. We're not searching for provision. We don't need provision. It will charge you for the whole thing. We need pay per request. This table looks good, and now we'll paste it here below the S3 bucket, and rename and remove the unnecessary things. Now that our both resources is set properly, our state backend is ready. Let's verify everything once. Everything looks good, and inside our project terraform.tf, first we need to actually create those two resources. So inside the state backend directory, we'll do terraform init to initialize the backend, and it will install the AWS provider. We have successfully initialized the backend. Let's now do terraform validate. So this means our code is correct and valid. So next we'll do terraform apply with the auto approve flag. It will not ask for any type of confirmation. It will automatically apply the changes. Now that our DynamoDB table and S3 bucket is created, we'll add them in our project. Bucket will give the name of the S3 bucket, and key, it is just the path where the state file will be. Here we'll give 3-tier project slash terraform.tf state. Okay, and next we'll give a region which is US West 1, and next we'll give the DynamoDB table, which name of the table is Terra state table, correct? Okay, now, and one more thing, we have to add a .gitignore file so that the state file is never committed into GitHub. Now let's start creating modules. Inside the project directory, we'll create a modules directory, and inside that we'll create a VPC directory, and inside this we'll add some files. Start with the resource.tf, and we'll need a resource for VPC, so let's find it. This is not this AWS VPC, yes, this one. We need a basic resource block, yes, this will do. We'll take it, and for the cider block we'll not hard code it, we'll use variables. So we'll remove this and change the tag and the name, and for the cider block, we'll inside the variables.tf we'll create a variable block, and we'll call it cider VPC, and next we'll add a description which is cider for VPC, and type will be string. Perfect. And now we'll use this variable in the cider block, var dot cider VPC, correct? And this value will be coming from terraform.tf vars. For this we also have to create a variable here also. Inside terraform.tf var we'll pass the value cider VPC, and in this we have to pass the cider block value. We'll use 20.0.0/16. Okay, and next we need a subnet, so let's find it. Yes, here, subnet, AWS subnet. We'll need this basic usage, we'll take it, and we'll change the name of the subnet. We'll create two subnet, public and private. For now let's keep it same as this. We'll change it because we have not created the variable for the subnet. The VPC ID, name of the VPC is Hulk VPC.id. Okay, and tag will use Hulk public subnet. Okay, and one more thing, we need public IP to the instance launch in this subnet. For that we have to add a property called map. Let's search it. Map, yes, this one, map public IP on launch. We'll copy it, and we'll set the value of it to be true. And this subnet will be created in a particular availability zone. For that we have to fetch the details from AWS. For that there is a property called, yes, this one, availability zone. What for this we have to, I guess we have to add a data source for this. So let's search data source for the availability zone. Yes, AWS availability zone. Yes, what it will do, it will fetch all the availability zones in the region, and it will give me a list of those availability zones. We have to create a new file here, data.tf. I will paste it here. Yes, what it will do, it will give me the list, and we'll use the list here. Data.availability dot names. And we will creating a second subnet, private subnet. So we'll copy and we'll reuse it here, and now we'll rename everything. Now everything is looking great. Only one thing we need to actually set the variables of the CIDR of the subnets. So for that we'll create variable in this module itself. Let's create two variables, one public and private, and copy this two variable block and paste in variable.tf in the root, and in terraform.tf vars we can pass the values 20.0.1/24. Yes, this will do. We'll do the same for the private. Okay, and this is VPC, and these value will be accessed here by var dot public CIDR VPC and var dot private VPC as well. Yes, everything is done, and we don't want any public IP in the private, so we'll remove that line. And yes, and next we'll need an internet gateway. Let's find internet gateway. Okay, yes, this one will take this one. Let's paste it here, and now oops. Okay, and next we'll need a route table. Let's find a route table. So, route table, yes, we'll take this, and this is for public, my public subnet. Let's add a comment here for table for public, and we don't need IPv6, so we'll remove this. And 0.0 for all outbound traffic. Okay, and gateway, internet gateway. Okay, it's done. VPC ID, we'll give a tag, and next we'll need a route table association. It makes a connection between the route table and the subnet, so the subnet will know which route table rules to follow. Yes, this is good. Yes, subnet ID is the public one, and route table, public route table ID. Okay, done. And we'll make the same for the private as well. Let's rename them after copying. and remove this. We don't need any outbound traffic in the private subnet. Everything is done. All is done. Let's verify once again. Yes. And now inside the modules.tf in the root directory, we'll make a module block, name it VPC, and in source we'll give the path of that VPC module, and we'll pass all the variables here one by one. Now let's save all the files and let's run in our VM. Let's do Terraform init first. It will initialize the backend and okay. Duplicate resource AWS route association. Okay, I think I have not changed the name here in the resource. Let's check. Yes, RTA and RTA, both are RTA. Let's change them. Let's again do Terraform init. Okay, Terraform has been successfully initialized. Now we'll do Terraform apply. See, it says acquiring state lock. It is acquiring a lock or putting a lock in the MongoDB or sorry DynamoDB table. I'll show you the table. Okay, we have an error. It says we have to okay data. What is the error? Everything says okay. Availability zones data. Okay, this is giving me a list, and we will use first element of the list in the public and the second element of the list in the private. We can use this is just like an array. Okay, this will work. We'll again do Terraform apply, and it's just asking for a confirmation. We'll say yes, and it will start creating all the resources. Now we can verify those resources in our AWS account. VPC, and let's see. Inside VPC, yes, it's created. Subnet, public and private, both are created. Route table are created. Internet gateway is created. And moving on, we'll create another module, security group. We'll require all the similar files, so just copy it. And wait, we have forgot to create output block for our VPC module. So let's just create it. Output block, what it does, it will give you the result, whatever resources it has created in the AWS. It will give the ID of or public IP in the console itself. copy it, and we have to paste it in the output of the root. The values flows from the module to the root. We have to change the value module.vpc.vpcid, like that. Let's pull and do Terraform apply, and see the acquiring. I will show you what it means. Now it is waiting, or it is in the process. Acquiring state log, I'll show you where it is now. See in the DynamoDB table, see here, if you refresh it, and you'll find this lock. This entry is a lock. It will not allow anyone to apply changes. I'll show you with an example. Let's say someone else is trying to apply changes here. Okay, we'll do Terraform apply in other terminal, and let's see what it says. Here, see what it says. It says Terraform error acquiring state log. Terraform acquires a state log to protect the state from being written by multiple users at the same time. See how cool is this? So anyone else cannot make changes to this. Once I said yes, and it is applied, the lock will be released, and if I refresh it here again, see the entry has gone. See, this is what it means to acquire state lock or state locking. Let's get back to our security group module. We'll search a security group module here. Security group module. I will take we'll take this. So here it is. We'll remove all the IPv6 so the ingress is the inbound traffic and egress is the outbound traffic. We'll do we'll open 3 ports, and let's first rename them. We need our VPC ID, so we cannot use the value directly. We have to go through root. For that we have to create variables. We'll name it VPC ID, and the description will give VPC ID for sub security group. Type is string, and in the modules.tf we'll create a new module block called SG security group. Source will give the path here, and we'll pass the VPC ID here from the VPC module, and now we can use that ID in our resource.tf in the security group module. var.vpcid, yes. And let's now change the tag. Okay, we'll call it Hulk security group. Let's see the inbound rules. We'll first name it. This is HTTPS, and we'll allow it from anywhere. Let's add a description, HTTPS. Okay, and this one will be HTTP 80, and this is SSH 22 port. Okay, let's add a comment here, outbound traffic, and these are inbound traffic. Okay, we forgot to change the security group ID here. In all these, this will be sg.id. Let's do find replace. it will do all at once. So save, let's save all the files and run in our VM. Let's do Terraform init. We have to do Terraform init every time we create a new module. It will initialize the module. And now we can do Terraform apply. Okay, we'll confirm it. It will create all the security group, and let's verify our security group if it is created or not. Let's see. Yes, it is created. A security group is created. Let's now create a output block also for the security group. Security group ID value is aws.id, correct, and we have to pass it in the root output file also. This is VPC and the security group, and here will be module.security id. Yes, let's now go to our next module, EC2 instance. It will have all the similar files, so let's just copy them. And now let's search for EC2 instance resource. Yes, and we will take the first one, copy it, and remove the data block because we will give the AMI value itself. Remove this, add count, and let's create three variables, AMI, instance types, and count in the variables.tf. Variable first one is AMI, copy them, and we'll put them in the variables.tf in the root, and pass the values in terraform.tf vars. Count will give 2 here, and now let's find the AMI. We will launch an instance Ubuntu, and with this we'll copy it, and T2 micro is free tier. We'll paste it here, and here T2.micro. In the module.tf we'll create a new module block, EC2 instance. Source will give the path here, and AMI and instance type and count, var dot count of instance. Perfect. And now we can use those values here, var dot AMI, instance type, and count of instance. Done. Now let's change this tag, and we'll create a key pair to SSH into the instance. Let's see how to create it. And it says you can't create it with Terraform. You have to, it says to see AWS documentation. Let's check it. And yeah, yes, it says you can create it with AWS CLI, which we have. So we'll create it with AWS CLI. Let's copy, and let's name our key pair Hull key pair. Okay, and okay, it says you have to specify a region. So how to specify a region? Yes, okay, We'll add a region here. Our region is US West 2, and our key pair is created. Private key is in the AWS account, and we got our public key. Let's move this public key in our Windows machine from where we will do SSH. Here we can add the name of our private key. Now we need to put our instance in a security group and our subnet. For that, there is a property called VPC security group ID, and for subnet there is subnet ID. Yes. Now to get these values, we have to create variables. First we'll create a security group variable. In the module.tf, we'll pass the security group ID to be accessible in the module. Now we can use the variable here, and remember this is a list. And now for the subnet ID we'll do the same. Next, I want a public IP to be associated with this instance. For that, there is a property called associate public IP address. Yes, this one. This is a boolean value and it will be true. And for provisioning, we can use this user data. We can add a script here. It will always run the script before starting the instance. Let's create a script file in same level as the module. We'll create a simple script to install Nginx. Let's save our file and try to run this module. Let's do Terraform validate, and it says script path is not valid. Okay, so let's fix it. Let's add a path.module variable here. Sorry, path.module, it will figure out the path. Our instance is created. Let's verify it. In the security group, yes, all 3 ports are there. Our 2 instances are there. Let's see if Nginx is running. Yes, Nginx is also running. In the second one, let's see in this. Yes, Nginx is running in both. Perfect. The only issue I see is both instances have the same name, so we can fix it by adding a variable in the tag count.index. Now we can differentiate between two instances. Now let's create another module for application load balancer. So in this we'll create application load balancer, then target group, then we'll create or attach the target group to the application load balancer, and last we'll create a listener. So let's find the resources for this. So let's see, we need application load balancer. We'll take this and let's rename. We don't need access logs and we don't need deletion protection, so we'll remove it. For security group and subnet, let's create a variable. Now let's get this value via module.tf in the root. We'll create a module block here. Now let's use these values here, security group and subnet. Done. Now let's find target group. Yes, we'll take this resource block. Okay, now let's rename, give a name, target group, and VPC ID. I will get VPC ID. For that we have to again create a variable. We will pass the value here in the module.tf. Now we can use the value in our module. Now let's give a proper name and tag. Next we'll need to attach target group to our application load balancer. Yes, this one, and we'll take this and let's name it. So let's give my target group ARN and target ID its instance ID. To get this we have to create a variable to fetch it from the EC2 instance module. And type, we have more than one instance, so it is a list of strings. Let's add this variable in the modules.tf. It seems we have not created output for the instance ID. Let's create it. Value is AWS instance dot name of the instance dot every instance dot its ID. Okay. Note here we are getting the value from AWS, and inside the root output.tf we are fetching that value from the module to our root and printing it. Now that we got our instance ID, we can use it. We can pass it in the application load balancer module, and inside the resource.tf we can use the ID. Just because we are using more than one instance, so we'll use count to find the number of instance, and in target ID we'll just give the instance ID, and count dot index to iterate over all the instance ID because it is a list. So it's done, and last we'll search for listeners, and we'll take this resource and let's Modify the values. We'll remove the SSL policy. Port is 80 and ARN, target group ARN. Name will give listener and load balancer ARN, and let's save the changes. So everything is look okay. We have an error. It says AWS subnet is not defined. Okay, the syntax is wrong. Let's check now. We have a new error. It says value is not suitable. Okay, so maybe this is not a list. It doesn't take a list. Now we have a new error. Now it says at least two subnets in two different ability zones must be specified. Okay, so here I have only one. Let's make it a list, and our variable takes a string, not a list, so change that. And now we'll pass both public and private subnet here. Okay, and now we can use those public and private subnet, and this is a list, so we can use its index values to access those elements. Let's now save and check. And it is created. And the last error wanted me to put the subnets into different availability zones. So let's now verify that our application load balancer is created, and if we see our listener is also created. It seems I have not created the name of my ALB. Let's rename our application load balancer. And last, we'll create a RDS module. Let's find a resource for our RDS. Let's find, yes, we'll take this, and let's change the names. Next we need to add security group and subnet ID. Let's now create a variable for both. And in the root module.pf we'll create a module block also. We'll name it RDS. Source will give the path of the module. VPC, sorry, the security group ID, and the private subnet. Now we'll use those values in our module. See, this is security group IDs. It is more than one, so it's giving us a hint that it is not a string. It is a list, and the subnet. And now we'll save it and test. So there is a error. It says DB subnet group not found, fault. Okay, let's see. There is a DB subnet group here. Yes. So it will provide the group of the subnet. This resource will provide the RDS, the group of the subnet. So we'll take it, and top of that, yes, let's modify the values. Let's put the subnet variable here. Now let's recheck. Let's see how it goes. Here we have two errors now. The DB subnet does not meet the availability requirement. Add subnet to cover at least two availability zones, and DB subnet group not found. Okay, let's see. So here we have to give the name of our subnet, DB subnet group, not the variable. So remove this, and we have to create another private subnet. We'll create an identical copy of our current private subnet with a different name. Now that we have all set, we can pass the value here in the subnet group inside RDS module, and we can name the subnet group name here. Now let's save and run. So our RDS is created. We can verify it in our AWS account. Let's see. We'll refresh it and it's created. And yes, we forgot about the key pair we created. Let's also verify them by SSH into one of the instance. Let's copy this command and try to SSH. Yeah, I think we can. Perfect. Our Nginx should be running, so let's check its status by systemctl status Nginx. Yes, it's running. So let's delete or destroy our infrastructure with Terraform destroy. It will destroy all the infrastructure created. So this is it. I had fun making this project, and the link for this project will be in the description. And thanks for watching.